here to give you a bit of a history lesson, a lesson about one of the aspects of JavaScript that sets it apart from just about every other language being used at its scale, prototype-based object orientation. So, y'all are at a JavaScript conference, so I'm sure at least some of you have heard this term before. Others might be familiar with people talking about just OOP or object orientation, but what is this whole prototype thing? Well, since there's probably more people used to thinking in class-based languages, I'll try and explain that in terms of that. Pardon the Ruby. So think of it this way. Classes are like blueprints, right? They define the structure and behavior of objects. They're not objects themselves, and then you create a bunch of similar objects based on that blueprint. Like in this Ruby code here for creating a dog with a bark method. Now, when you want to create a new kind of object, you must first create a new kind of class, and then make a bunch of instances from that definition, but you always have to define an extra class. Now, prototypes are different. In prototype languages, you don't have any classes, you just make objects that could even work entirely on their own. So here's an example of a dog. It's just called a dog, and it has a bark method. We just create it with the literal object syntax. And hey, look, we can use the dog by itself. So if we want to have a more specialized kind of dog, we just clone our dog prototypes, specialize only the things that we need in, like, just to be more specific about it, or just change the name, and we can start using it right away. This mechanism where clones are able to reuse their parents' code is called delegation in prototype-based languages. In this case, Dogen is using the bark method from its parent, but its local name property. So why am I talking about this? Because JavaScript is very, very much a prototype-based language. Anything we do with objects with JavaScript always goes back to the behavior of its prototypes. And this bears repeating. JavaScript has no actual classes. All this stuff we use, like constructor functions, are just a little bit of sugar over the underlying prototypes. Here you can see I'm reusing the old dog prototype that we created a couple slides ago, and I'm just assigning it to the constructor's prototype property. And that, that sets up a bunch of mechanisms around new, but it's still a prototype. Even the new class syntax is just papering over prototypes just to give folks something more familiar. But believe me, you're always working with prototypes, whether you notice them or not. And so why does this distinction matter? Because prototypes have always been about interaction, flexibility, and play. They've been about creating programming experiences where the way that we interact with our programs feels more tangible and closer to objects in the real world. I know this might seem kind of abstract when I say it like that, and it is kind of like a weird distinction sometimes, but I hope that as we go on, this ends up making a lot more sense to you. Anyway, this talk isn't exactly about the mechanics of prototypes. This talk is about how this whole concept came to be, what ideas informed it, what we tried, what worked, what failed, what changed. It's about understanding why we did all of this. This talk is also about the future, because there's so much that our past can teach us about where we can go next. And when it comes to prototypes, their story begins about 40 years ago with a little language called Director. Now, I spent some time digging through papers and references and all that stuff for this talk, and as far as I could find, this is the earliest language that I'd say was recognizably prototype-based. But it didn't call itself that. It was actually trying to be an implementation of one of the hot new ideas at the time, 40 years ago, something called the actor model. And so the actor model is this way of working with concurrent applications. The gist of it is you have these objects called actors. Usually they're attached to some thread or a process or some concept of asynchrony. And you have them send messages to each other, literal strings of messages with like serialized objects to each other. And then whoever gets the message responds to it however it wants. And all it's got is a message. That's not Mike. So you might have heard of the actor model before in terms of a language called Erlang, which has ended up being kind of like the standard bearer for the idea, even though like that language popped up much later than the original actor papers. And so let's go back to director. The language was written as part of some early work on computer graphics, and as an implementation of the actor model, it used message passing for its operations. There was an ask function you could call on objects to send messages to them. So these were just like methods you might be used to. Actors would respond to it by just, running the code for that message. You can think of this ask thing as the dot operator in JavaScript. So director also had an async event loop that you could essentially schedule things into. It was not parallel, it was single-threaded, and it was a lot like JavaScript's own event loop. Finally, this is the first example I could find of delegation-based inheritance. So in director, you made new actors by cloning existing actors, and it provided all these like root utility actors. When you sent a message to that new actor, it would answer the message, it would try and answer the message itself. If it didn't have its own response, it would then ask its parent to answer it instead, and then the next parent, and so on, until either finding a matching message handler or failing. So this is a key feature here, because delegation, that process of inheritance, turns out to be one of the core principles of prototypes, and almost every prototype-based language since has used these semantics for its inheritance. It's probably like the most key part of the difference between classes and prototypes. So what did director look like? Here's some example code, just like a lot of language experiments of the day. This is very common. It was written on top of Lisp. So director was designed for computer graphics, like I said before. It used a style of graphics based on Logos Turtle programming. How many of you are familiar with Turtle? Wow, there's still a lot of you. Awesome. So basically, you have this thing called a turtle, which is the cursor, and you tell it which directions to move and how far. It's like the whole thing, like rotate left a little bit, go forward 10 steps. So that's called turtle programming. And in the end, you end up with a drawing. So looking at the code really quick. In the first line, you can see the cloning method I mentioned before, sending this make message to the movie actor, creates a new actor, and then assigns it to a variable called my first film. Right? It's Lisp. It looks weird, but it's kind of similar semantics to what we're used to. Cool. From there, you can send different draw messages to different actors representing graphics primitives. In this case, we had previously created a star and a pentagon. So that's what we're animating. Those are the two blocks in the middle. This plan message that we're sending to those things, that was how director would send work over to the event loop, the asynchronous event loop. And it would, just do it at the right time. Finally, at the bottom, at that last line, we tell our film to record in the next 4 seconds, and then we play back the scene it just recorded. And I do mean play it back. This is a film strip of what you'd end up seeing on your monitor. Which is pretty cool for 1978. Anyway, that's director. It would be a few more years before we stopped talking about actors when it came to semantics like these. A lot of them popped up since then, and even longer until we started calling them prototypes. Which brings us 9 years later to a language extension called ObjectList. I swear I'll stop with the Lisp soon. This was the first instance I could find of a prototype-based language that wasn't just trying to implement the actor-based model. So it was this language extension for Lisp, used mainly in Lisp machines by LMI. Lisp machines were these big old computers with a specialized architecture that did a lot of Lisp operations directly on the metal. It made Lisp easier to use as a systems language. They were popular with some researchers and AI folks at the time. They also had these operating systems that would let you manipulate running programs live with a dynamic programming language and even change the behavior of the operating system itself, just interactively. Lisp machines use ObjectList heavily for their UI work. Again, we see prototypes being a nice fit for interactively building graphical stuff. Now, as far as I can tell, no one was calling anything prototype-based OOP at the time. ObjectList just called itself object-oriented because it's objects, right? It emphasized that in the papers to distinguish itself from class-based programming. So this was a time before OOP meant what it means today. So again, some code. This is a little script using ObjectList to give you an idea of what it's like. Let's go over it real quick. So first, it defines an icon prototype in that first line. Then it adds a method called goToXY to this with this defOpFun operator, skipping the body. the body definition, and we see that it clones the icon prototype using kind of, and finally, it moves the clone to a certain XY coordinate on the screen by calling that method we define. Again, you see the infamous ask function getting reused here. Aside from the parentheses, I think this code would probably not be too foreign to a lot of people here, especially when you put it side by side with the equivalent JavaScript. You can just see how close the operations were to what we might be used to with JS, and Lisp even has the same variable scoping mechanisms. Looking at stuff like this is a big part of why I really love to look into language history. We're still using pretty much identical semantics in 2017 to what some folks were already using in production more than 30 years ago. To me, this slide here is incredibly validating about how solid the semantics we work with every day are. It means they've really held up to this test of time. And speaking of 30 years ago, happy 30th, Self. I'm sure some folks have heard of Self here. It's probably most famous for being the first fully prototype-based language, and a lot of people just consider it the first prototype OOP language, period. To this day, Self is probably one of the most important and innovative dynamic languages in the history of language theory, and I don't say that lightly. So Self was a research language at Xerox PARC, which was basically the skunkworks R&D department of Xerox. An incredible amount of cool stuff came out of there that we take for granted these days. Laser printers, bitmaps, the GUI, along with the mouse, Ethernet for local networks, Smalltalk, and the model view controller architecture, just to name a few things. And it's kind of jaw-dropping how much they did. So Self came out of this amazing place as something that built on top of the earlier Smalltalk language, which was class-based. But it just used prototypes instead. Now, prototypes, it turns out, and as we keep seeing, were particularly great at graphical work. Self doubled down on this a lot, making the entire development experience based around manual interaction with actual objects. You want to have a new type of green ball? Just clone one of them and start hacking away. There was no need to do the individual class definitions you'd had with Smalltalk, and the user experience of building applications by clicking on things was just so much smoother than it was with that other one. So just like Smalltalk, Self had no source files, and this is kind of weird for me. The way you wrote applications was literally you run a visual program and you start clicking around. All your code would then just exist inside these visual elements. There was no building, no compiling, building, or text-based source control or any terminal work. You did the entire thing graphically. Like you can literally see this velocity method is just hacked directly into a box and an object, or morph as they call them. And so those graphics were a pretty heavy load in 1985, so the Self devs ended up putting an immense amount of effort and research into making this prototype stuff go very, very fast. Some of this optimization work had already been done with Smalltalk, like inline caches, but prototypes had special needs. The whole point of this was to have their cake and eat it too, right? They wanted all the ease of use of a very dynamic system, but with speed to match lower level and even systems languages. And they actually kind of delivered on it. Many of the optimizations that Self pioneered ended up being used years later by JavaScript engines, particularly V8. You know, the hidden classes thing, that came from Self. Self also explored the semantics of this concept of prototypes. They played around with different types of inheritance, including multiple inheritance and traits. They played around with semantics for properties, and then took all of this stuff and published a bunch of papers on it so future generations could benefit. You can even read them today. Of any of the languages I'm going to talk about today, I think it's safe to say that Self had the single biggest influence on modern JavaScript than any other, and I think there's a lot of inspiration we can take from it, even now. Now, for something a little different, instead of graphics, let's talk about a cute little language that used prototypes for really creative things in a text-based world. Now, LambdaMu was both the name of a programming language as well as the game that used that language to build this little virtual world. How many of you are familiar with MUDs? How many of you have actually played them? I love y'all. I spent so much time on these things. Okay, so MUDs were basically the precursors to MMO games. They were online, they were multiplayer, and they were text-based instead of having like clicky graphical things. You would literally telnet in, and you'd get this text adventure game that you could enjoy with others. The acronym itself stands for Multi-User Dungeon. So LambdaMu was one of these, and it was founded at Xerox PARC by someone in the language research department 3 years after Self first came out. The thing that really set LambdaMu apart at the time was that it allowed players themselves to make or modify objects inside the world. A player could log on and start directly manipulating things without needing to be a GM or wizard or whatever. So pardon me, I want to walk you through this because it's really exciting. So the first thing you do is you connect to it, right? Obviously, little angle brackets are my input. Once we're connected, you'll see we're dropped into this first room. There's not much else in the game because we haven't built it yet, so let's build something. First thing is, we dig out a room to the north with the @dig command. You can see @dig and north. We'll call it Academy of Medicine. And that's it. We have a whole room now in this game. That number is the unique object ID for that room object, and every object in LambdaMu had a globally accessible ID because you were just manipulating this whole world. Then we type north to move into that new room, and it doesn't have a description. So we'll give it one with the @describe command. And ta-da, welcome to EmpireConf Mu. So let's move on to putting things inside that room that we can interact with. @create makes a new object here called audience. The $thing argument here is the prototype. We're basing the audience on a generic thing. Again, we give it a description, just like the rooms. Take a look at it. Finally, we use the @verb and @edit commands to add a new verb that will act on the audience. And that drops you into a whole editor, and you do stuff. And that's it. That's kind of what the experience of playing and programming LambdaMu looked like. There's a full programming language with the usual bells and whistles, and if you wanted to write more complicated logic, but if you just wanted to build some rooms and be creative, that was actually really accessible. This thing is still running, by the way. It's been 27 years, and there's still people playing this. You can use this command, that telnet command right now on your computer, to log in and start exploring if you want. So we are done with ancient history at this point. I've got 2 more languages to talk to you about, and they're both still in widespread use today. They're both from around the same time and turned out to be pretty similar. The first is Lua. So Lua is not an acronym. It means moon in Portuguese. And it was created by members of something called the Computer Graphics Technology Group at the Pontifical Catholic University of Rio de Janeiro. So the thing is that at the time, there were a bunch of trade barriers for importing software to Brazil. So they either had to fork all this money over to get things, or they could write their own, right? So by writing your own versions of a lot of software is pretty rough. If you wanted to be able to prototype things really quickly, though, and you don't care about like the same kind of maturity, it turns out that having a good dynamic language could help make that happen. So, they looked at Tickle, and it didn't really tickle their fancy. They really liked list semantics, but they hated the list syntax. And finally, since this was going to be used for computer graphics software, it needed to be both fast and embeddable. That is, it needed to play nicely with the lower level C and C++ code for the most performance and sensitive bits. So this is what we ended up with. Lua called its objects tables, and it ended up doing inheritance through something called metatables, which is really just a prototype chain mechanism. It's really, really fast enough that it ended up getting adopted by most of the games industry as a scripting language for their game logic. And if you know about the games industry, they're kind of obsessed about performance. And so by this point in time, we've seen prototype languages go back to something like ObjectList semantics from years ago. In fact, this Lua code that sets up a 3D vector prototype maps almost directly to how you'd usually write it in JavaScript and ObjectList. The main difference being that setting up the metatables involves a bit more manual setup than JavaScript construction functions, but that's just a bit. As I mentioned before, Lua is still in wide use today. It's a cute, fun little language that really shines in the areas that it was designed for. Much like the last language that I'm going to talk about here. Can you guess which one it is? You can shout it out. The one that this conference is all about, of course. At this point, we've covered about 20 years of history, right? And JavaScript came out a little over 20 years ago, and that's a long time. So what is this JavaScript thing, and what did we learn from it? Well, first of all, it's the most widely used prototype-based language in the world, and based on some statistics, there's probably now more code written in JavaScript than any other language in history. That's a pretty big deal. JS was created by Netscape as a scripting language for early web browsers. They literally just wanted to move pictures around on a web page and win the browser wars. They did have some requirements for the language. JS was born, it was born to the browser war where different vendors were competing with each other pretty aggressively for market share, and any small edge in features could push you right past the competition. There were two big constraints here. First, it needed to be really easy to learn. Second, it needed to be written very, very quickly. The first prototype was famously written in just 10 days, and it was basically a cobbled together version of Scheme, Self, and because Java was the hot new thing back then, they really just kind of slapped Java syntax on it and named it JavaScript. Like, that was literally, they were making deals with folks, but anyway, that's pretty much it. This is how our beautiful, problematic child was born. Even so, it's really great. It's grown a lot since it attained the prototype. Prototypes turned out to be a great match for the DOM and the platform in general. The goal of being easy to use worked out great, too. JavaScript ended up ushering an entire generation of programmers into this exciting new web platform. That's a lot of you right here, probably. So many of us just learned to program by opening up an HTML file and playing around with things until they kind of sort of worked. It's 2017. To be honest, that part hasn't changed too much, not for me at least. We also have an actual standard for the language now, and for the past few years, it's been evolving aggressively, incorporating features of other languages and doing its best to keep up with the times. JS might be 20 years old, but it's most definitely a modern language in 2017. So, to recap real quick, Director was the first language with prototype-like features and used for early graphics. ObjectList came almost a decade later as a tool for UIs and an operating system made with secret alien technology. Self took all these ideas, doubled down on it with a pure prototype language, and then optimized the ever-loving goodness out of it. Then wrote a bunch of papers, and JS engines still use the tech today. LambdaMu was made by some Self people, and it made it easy for an entire online community to craft a world and tell their stories together without having to learn a lot about coding. Lua is used by a bunch of game devs. It's fast, semantically very close to JavaScript, and it's probably the second most popular prototype programming language. And finally, JavaScript is the thing this whole conference is about, as I've said, I think 4 times now. And you should go to the other talks to learn more about it. So that's it. That's my little overview. Where do we go from here, though? How can we take all these history lessons and apply them to the modern world? For one, I think it's a great idea for us to go back to emphasizing interactive development. This is really where prototypes have always shined. As ES Next starts making it into browsers, I hope the need for tools like Babel or Webpack starts disappearing, and we can focus more on interacting with the platform directly. That also means continuing all the development going on with browsers DevTools. These are really great descendants to development tooling that Self pioneered. With ES Module's new live binding exports, there's a whole world of interactive dev that we still haven't quite explored. Finally, I think the work that's been going on with web components for the past few years is fantastic. Web components are basically this way to clone and customize actual DOM elements, meaning you can play with your app right in the DevTools HTML inspector. I think that's probably kind of controversial, but I totally think that based on everything I've talked about, web components are the most natural evolution of the web platform. I think they're going to make the web a lot more accessible to new developers, and they're going to open doors we still can't quite imagine. So, kind of continuing down that path, it's really important to keep JavaScript easy. There's this Self paper titled The Power of Simplicity that really drives this point home. Simple, easy to learn languages help adoption. It's up to us to do everything we can without piling layers and layers of complexity over it. The web platform is essentially a little operating system after all, but with these APIs exposed that give you access to OS APIs that would usually be much more complicated. Let's keep this immediate results thing going. Let's make it so you can nudge something around in your browser and see the changes right away. Let's prioritize that. There was a talk yesterday. Did Jennifer actually speak? I assume she did. I was crashing. I love the things that that glitch.com has been doing to support this sort of thing. You should really check it out. Glitch is awesome, just saying. So they say those who don't learn from history are doomed to repeat it, but I think that when it comes to programming languages, repeating it is exactly what we want to do more of, and how we can figure out where we can go, how we can go forward. I'll leave you with this little note from our infamous horsey friend. Thank you very much, and happy hacking.
Thank you, Kat. Kat.
Oh no! Oh no! It's the Q&A.
You don't have to if you don't want to.
I'm here on the spot.
So, well, one thing, we just want to grab your computer really quickly.
No, why are you?
Because they're gonna. This is so we can distract them from setting up the next person. I don't need the computer. It's a magic. It's an illusion, Michael.
You want to check out my stickers? Look at my stickers. I have a lot.
So if everyone just looks right over here. No, but so you talk about all these prototype languages. Yes. When do you think the languages are going to go to production?
Next sprint.
Quarter 1, 2018, JavaScript's going production. You heard it here.
Awesome. Okay. So I am more interested in your work at NPM.
What? Okay.
Well, not more interested.
Hi.
It's all interesting. But I thought it would be really awesome to hear from you one of your favorite tips or things that you like to tell people that maybe a lot of people don't know that are on the command line every day.
I'm gonna I have literal talks about this. I can spend an hour on this. NPM 5 is great. You should try NPX. Have you tried it? Has anyone tried NPX yet? Woo! Oh, you should totally try NPX. Just install the latest NPM, and it's really cool. We also have a CI-oriented package manager that's it's the fastest package manager on the market right now by far. Significantly faster than anything.
And you've released this now?
I mean, there's a beta version out. There's kind of a crappy development version that I've been releasing. You can just npm install CIPM and try it out.
CIPM?
CIPM.
CIPM.
Yeah, we're integrating that into NPM eventually, so you'll have really, really, really fast CI-specific installs.
Now, is this something that could be used in lieu of npm install production, or not for production environments?
No, it's either. You can use it in continuous integration, continuous deployment, whatever. It's just a dedicated installer.
That's really cool. I personally appreciate all the hard work that. Is it fair to call you all wombats? Is that?
I appreciate all our hard work too.
So for all of those of you who are not familiar with it, there is a small Wombat developer union. Yeah, it's covered by the Happy. That game turned out really nice. You all can't see it, but just trust me. Cool. Well, thank you so much, Kat. Big round of applause for Kat Marchand. And if you just follow us this way.